And okay. So we are on chapter number 11, fine tune large language models. We did do fine tuning a pre-trained model earlier, uh, जिसमें हमने नया डेटा सेट लिया स्पेसिफिक और उस पर फाइन ट्यून किया ट्रेनर एपीआईज लेके या ये एपीआई लेके, बट उसमें हमने पूरा का पूरा मॉडल ही रीट्रेन हो रहा था. बट आई गेस आपका डेटा सेट बहुत छोटा है वगैरह तो सब सही है कि तब भी थोड़ा फास्ट हो जाएगा, लेकिन बहुत बड़ा डेटा सेट है या मॉडल बहुत ज़्यादा है, then I think it will be problematic and you need better ways of doing. Uh, so the generative language models can be fine-tuned on specific tasks like summarization, question answer. However, nowadays it is far more common to fine-tune language models on a broad range of tasks simultaneously. A method known as supervised fine-tuning. Right? This process helps model become more versatile and capable of handling diverse use cases.
तो इतनी देर हम लोग सुपरवाइज नहीं कर रहे थे क्या? ये तो सुपरवाइज ही था.
सुपरवाइज था ही वैसे तो. आई थिंक या जितना मैंने ऊपर ऊपर से ये पढ़ा, यू रिमेम्बर अपन ने एक बार वो डिस्कस किया था कि वो क्या सारे पैरामीटर्स के वेट्स को ट्यून करेगा कि नहीं. दिस प्राइमरीली फ्रॉम व्हाट आई हैव रेड, लॉरा वगैरह. एक ही मिनट है, मैं घर पे कोई है उसको दबा. ठीक है, स्पेकुलेशन से पहले अपन आई थिंक एक बार लेके जाते हैं. बट माई बिलीफ इज कि ये एडाप्टर मॉडल टाइप का कुछ है जिसमें यू डोंट हैव टू रिट्रेन द होल थिंग. लाइक इफ इट्स अ वेरी बिग मॉडल लाइक 7 whatever 100 billion parameters, and तो उस केस में you only fine tune a subset of those weights parameters, and that you achieve through what you call as low rank adaptation. And this is possibly some adapter based ये as opposed to जो जेनेरिक प्री फाइन ट्यूनिंग अपन ने देखा था जिसमें अपन ने ऐसा कुछ ये नहीं किया था. So we saw that generative ये सब हुआ. We'll separate this chapter into 4 sections. Chat templates. The template structure interaction between the users and AI models, ensuring consistent and contextually appropriate responses. These include components like system prompts and role-based messages. Supervised fine-tuning is a critical process for adapting pre-trained language models to specific tasks. It involves training the model on a task-specific dataset. Label examples. For a detailed guide on SFT, low rank is a technique of fine-tuning language models by adding a low-rank matrices to the model's layers. This allows for efficient fine-tuning while preserving model's pre-trained knowledge. One of the key benefits of LoRa is the significant memory savings and evaluation. Chat templates are essential for structuring interaction between language model and users, whether you are building how to properly convert your conversation to what chat. base model is trained on raw data. It's fine-tuned specifically to follow instruction engaging conversation. Is fine-tuning is part of what you call as like post-training, right? Like even for
Okay.
these models.
Mm-hmm.
Uh,
Hello, my name is.
uh, ये मुझे बस एक
Everyone. Okay, so this is the kind of brief summary of the things we talked about over the last few minutes. Now, let me zoom out here.
Sound share
And this is kind of like, what we've talked about so far. We wish to train LLM assistants like ChatGPT. We've discussed the first stage of that, which is the pre-training stage. And we saw that really what it comes down to is we take internet documents, we break them up into these tokens, these atoms of little text chunks, and then we predict token sequences using neural networks. The output of this entire stage is this base model. It is the setting of the parameters of this network. And this base model is basically an internet document simulator on the token level. So it can just, it can generate token sequences that have the same kind of like statistics as internet documents. And we saw that we can use it in some applications, but we actually need to do better. We want an assistant. We want to be able to ask questions, and we want the model to give us answers. And so we need to now go into the second stage, which is called the post-training stage. So we take our base model, our internet document simulator, and hand it off to post-training. So we're now going to discuss a few ways to do what's called post-training of these models. These stages in post-training are going to be computationally much less expensive. Most of the computational work, all of the massive data centers, and all of the sort of heavy compute and millions of dollars are the pre-training stage. But now we go into the slightly cheaper, but still extremely important stage called post-training, where we turn this LLM model into an assistant. So let's take a look at how we can get our model to not sample internet documents, but to give answers to questions. So in other words, what we want to do is we want to start thinking about conversations. And these are conversations that can be multi-turn, so there can be multiple turns, and they are, in the simplest case, a conversation between a human and an assistant. And so, for example, we can imagine the conversation could look something like this. When a human says, what is 2 plus 2, the assistant should respond with something like 2 plus 2 is 4. When a human follows up and says, what if it was star instead of a plus, assistant could respond with something like this. And similar here, this is another example showing that the assistant could also have some kind of a personality here, that it's kind of like nice. And then here in the third example, I'm showing that when a human is asking for something that we don't wish to help with, we can produce what's called a refusal. We can say that we cannot help with that. So in other words, what we want to do now is we want to think through how an assistant should interact with a human. And we want to program the assistant and its behavior in these conversations. Now, because this is neural networks, we're not going to be programming these explicitly in code. We're not going to be able to program the assistant in that way. Because this is neural networks, everything is done through neural network training on data sets. And so because of that, we are going to be implicitly programming the assistant by creating data sets of conversations. So these are 3 independent examples of conversations in a data set. An actual data set, and I'm going to show you examples, will be much larger. It could have hundreds of thousands of conversations that are multi-turn, very long, etc., and would cover a diverse breadth of topics. But here I'm only showing 3 examples. But the way this works basically is assistant is being programmed by example. And where is this data coming from? Like 2 times 2 equals 4, same as 2 plus 2, etc. Where does that come from? This comes from human labelers. So we will basically give human labelers some conversational context, and we will ask them to basically give the ideal assistant response in this situation. And a human will write out the ideal response for an assistant in any situation. And then we're going to get the model to basically train on this and to imitate those kinds of responses. So the way this works then is we are going to take our base model, which we produced in the pre-training stage, and this base model was trained on internet documents. We're now going to take that data set of internet documents and we're going to throw it out, and we're going to substitute a new data set. And that's going to be a data set of conversations. And we're going to continue training the model on these conversations, on this new data set of conversations. And what happens is that the model will very rapidly adjust and will sort of like learn the statistics of how this assistant responds to human queries. And then later during inference, we'll be able to basically prime the assistant and get the response, and it will be imitating what the human labelers would do in that situation, if that makes sense. So we're going to see examples of that, and this is going to become a bit more concrete. I also wanted to mention that this post-training stage, we're going to basically just continue training the model, but the pre-training stage can in practice take roughly 3 months of training on many thousands of computers. The post-training stage will typically be much shorter, like 3 hours, for example. And that's because the data set of conversations that we're going to create here manually is much, much smaller than the data set of text on the internet. And so this training will be very short, but fundamentally, we're just going to take our base model, we're going to continue training using the exact same algorithm, the exact same everything, except we're swapping out the data set for conversations. So the questions now are, what are these conversations? How do we represent them? How do we get the model to see conversations instead of just raw text? And then what are the outcomes of this kind of training? And what do you get in a certain like psychological sense when we talk about the model? So let's turn to those questions now. So let's start by talking about the tokenization of conversations. Everything in these models has to be turned into tokens because everything is just about token sequences. So how do we turn conversations into token sequences is the question. And so for that, we need to design some kind of an encoding. And this is kind of similar to, maybe if you're familiar, you don't have to be, with, for example, the TCP/IP packet on the internet. There are precise rules and protocols for how you represent information, how everything is structured together so that you have all this kind of, and so it's the same thing now happening like conversations. Now, how I would recreate this conversation in the token space. So if you go to Tick Tokenizer, I can take that conversation, and this is how it is represented in for the language model. So here we are iterating a user and an assistant in this 2-turn conversation. And what you're seeing here is, it looks ugly, but it's actually relatively simple. The way it gets turned into a token sequence here at the end is a little bit complicated, but at the end, this conversation between a user and assistant ends up being 49 tokens. It is a one-dimensional sequence of 49 tokens, and these are the tokens, okay? And all the different LLMs will have a slightly different format or protocols, and it's a little bit of a Wild West right now. But for example, GPT-4o does it in the following way. You have this special token called IM_start, and this is short for imaginary monologue, the start. Then you have to specify, I don't actually know why it's called that, to be honest. Then you have to specify whose turn it is. So for example, user, which is a token 1428. Then you have internal monologue separator, and then it's the exact question, so the tokens of the question. And then you have to close it, so IM end, the end of the imaginary monologue. So basically, the question from a user of what is 2 plus 2 ends up being the token sequence of these tokens. And now the important thing to mention here is that IM_start, this is not text, right? IM_start is a special token that gets added. It's a new token. And training stage are introduced and it's a new start of a turn, and it is by the assistant. And then what does the assistant say? Well, these are the tokens of what the assistant says, etc. And so this conversation is now turned into this sequence of tokens. The specific details here are not actually that important. All I'm trying to show you in concrete terms is that our conversations, which we think of as kind of like a structured object, end up being turned via some encoding into one-dimensional sequences of tokens. And so because this is a one-dimensional sequence of tokens, we can apply all the stuff that we applied before. Now it's just a sequence of tokens, and now we can train a language model on it. And so we're just predicting the next token in the sequence, just like before, test time during inference. So say we've trained a model, and we've trained a model on these kinds of data sets of conversations, and now we want to inference. So during inference, what does this look like when you're on ChatGPT? Well, you come to ChatGPT and you have, say, like a dialogue with it. And the way this works is basically, say that this was already filled in. So like, what is 2 plus 2? 2 plus 2 is 4. And now you issue what if it was times IMEnd. And what basically ends up happening on the servers of OpenAI or something like that is they put in IMStart assistant, IMSep, and this is where they end it, right here. So they construct this context, and now they start sampling from the model. So it's at this stage that they will go to the model and say, okay, what is a good first sequence? What is a good first token? What is a good second token? What is a good third token? And this is where the LLM takes over and creates a response. Like, for example, response that looks something like this, but it doesn't have to be identical to this, but it will have the flavor of this if this kind of a conversation was in the dataset. So that's roughly how the protocol works, although the details of this protocol are not important. So again, my goal is just to show you that everything ends up being just a one-dimensional token sequence, so we can apply everything we've already basic this. The first paper that I would like to show you, and the first effort in this direction, is this paper from OpenAI in 2022. And this paper was called Instruct GPT, or the technique that they developed. And this was the first time that OpenAI has kind of talked about how you can take language models and fine-tune them on conversations. And so this paper has a number of details that I would like to take you through. So the first stop I would like to make is in section 3.4, where they talk about the human contractors that they hired, in this case from Upwork or through Scale AI, to construct these conversations. And so there are human labelers involved whose job it is professionally to create these conversations. And these labelers are asked to come up with prompts, and then they are asked to also complete the ideal assistant responses. And so these are the kinds of prompts that people came up with. So these are human labelers. So list 5 ideas for how to regain enthusiasm for my career. What are the top 10 science fiction books I should read next? And there's many different types of kind of prompts here. So translate this sentence from to Spanish, etc. And so there's many things here that people came up with. They first come up with the prompt, and then they also answer that prompt, and they give the ideal assistant response. Now, how do they know what is the ideal assistant response that they should write for these prompts? So when we scroll down a little bit further, we see that here we have this excerpt of labeling instructions that are given to the human labelers. So the company that is developing the language model, like for example, OpenAI, writes up labeling instructions for how the humans should create ideal responses. And so here, for example, is an excerpt of these kinds of labeling instructions. On a high level, you're asking people to be helpful, truthful, and harmless. And you can pause the video if you'd like to see more here. But on a high level, basically just answer, try to be helpful, try to be truthful, and don't answer questions that we don't want kind of the system to handle later in ChatGPT. And so roughly speaking, the company comes up with the labeling instructions. Usually they are not this short. Usually they are hundreds of pages, and people have to study them professionally. And then they write out the ideal assistant responses following those labeling instructions. So this is a very human-heavy process, as it was described in this paper. Now, the dataset for Instruct GPT was never actually released by OpenAI, but we do have some open source reproductions that were trying to follow this kind of a setup and collect their own data. So one that I'm familiar with, for example, is the effort of Open Assistant from a while back. And this is just one of, I think, many examples, but I just want to show you an example. So here's, so these were people on the internet that were asked to basically create these conversations similar to what OpenAI did with human labelers. And so here's an entry of a person who came up with this prompt. Can you write a short introduction to the relevance of the term monopsony in economics? Please use examples, etc. And then the same person, or potentially a different person, will write up the response. So here's the assistant response to this. And so then the same person or different person will actually write out this ideal response. And then this is an example of maybe how the conversation could continue. Now explain it to a dog. and then you can try to come up with a simpler explanation or something like that. Now, this then becomes the label, and we end up training on this. So what happens during training is that, of course, we're not going to have a full coverage of all the possible questions that the model will encounter at test time during inference. We can't possibly cover all the possible prompts that people are going to be asking in the future. But if we have a data set of a few of these examples, then the model during training will start to take on this persona of this helpful, truthful, harmless assistant. And it's all programmed by example. And so these are all examples of behavior. And if you have conversations of these example behaviors, and you have enough of them, like 100,000, and you train on it, the model sort of starts to understand the statistical pattern, and it kind of takes on this personality of this assistant. Now, it's possible that when you get the exact same question like this at test time, it's possible that the answer will be recited as exactly what was in the training set, but more likely than that is that the model will kind of like do something of a similar vibe, and it will understand that this is the kind of answer that you want. So that's what we're doing. We're programming the system by helpful, truthful, harmless assistant, which is kind of like reflected in the labeling instructions that the company creates. Now I want to show you that the state of the art has kind of advanced in the last 2 or 3 years since the InstructGPT paper. So in particular, it's not very common for humans to be doing all of the heavy lifting just by themselves anymore. And that's because we now have language models, and these language models are helping us create these data sets and conversations. So it is very rare that the people will like literally just write out the response from scratch. It is a lot more likely that they will use an existing LLM to basically like come up with an answer, and then they will edit it or things like that. So there's many different ways in which now LLMs have started to kind of permeate this post-training stack. And LLMs are basically used pervasively to help create these massive data sets of conversations. So I don't want to show, like UltraChat is one such example of like a more modern data set of conversations. It is to a very large extent synthetic, but I believe there's some human involvement. I could be wrong with that. Usually there will be a little bit of human, but there will be a huge amount of synthetic help. And this is all kind of like constructed in different ways. And UltraChat is just one example of many SFT datasets that currently exist. And the only thing I want to show you is that these datasets have now millions of conversations. These conversations are mostly synthetic, but they're probably edited to some extent by humans. And they span a huge diversity of sort of areas and so on. So these are fairly kind of like gone in that direction since. But roughly speaking, we still have SFT datasets. They're made up of conversations. We're training on them just like we did before. And I guess like the last thing to note is that I want to dispel a little bit of the magic of talking to an AI. Like when you go to ChatGPT and you give it a question and then you hit enter, what is coming back is kind of like statistically aligned with what's happening in the training set. And these training sets, I mean, they really just have a seed in humans following labeling instructions. So what are you actually talking to in ChatGPT? Or how should you think about it? Well, it's not coming from some magical AI, like roughly speaking. It's coming from something that is statistically imitating human labelers, which comes from labeling instructions written by these companies. And so you're kind of imitating this, you're kind of getting, it's almost as if you're asking a human labeler. And imagine that the answer that is given to you from ChatGPT is some kind of a simulation of a human labeler. And it's kind of like asking, what would a human labeler say in this kind of a conversation? And it's not just like, this human labeler is not just like a random person from the internet, because these companies actually hire experts. So for example, when you are asking questions about code and so on, the human labelers that would be involved in creation of these conversation datasets, they will usually be educated, expert people. And you're kind of like asking a question of like a simulation of those people, if that makes sense. So you're not talking to a magical AI, you're talking to an average labeler. This average labeler is probably fairly highly skilled, but you're talking to kind of like an instantaneous simulation of that kind of a person that would be hired in the construction of these datasets. So let me give you one more specific example before we move on. For example, when I go to ChatGPT and I say, recommend the top 5 landmarks to see in Paris, and then I hit enter. Okay, here we go. Okay, when I hit enter, what's coming out here, how do I think about it? Well, it's not some kind of a magical AI that has gone out and researched all the landmarks and then ranked them using its infinite intelligence, etc. What I'm getting is a statistical simulation of a labeler that was hired by OpenAI. You can think about it roughly in that way. And so if this specific question is in the post-training data set somewhere at OpenAI, then I'm very likely to see an answer that is probably very, very similar to what that human labeler would have put down for those 5 landmarks. How does the human labeler come up with this? Well, they go off and they go on the internet and they kind of do their own little research for 20 minutes and they just come up with a list, right? Now, so if they come up with this list and this is in the data set, I'm probably very likely to see what they submitted as the correct answer from the assistant. Now, if this specific query is not part of the post-training data set, then what I'm getting here is a little bit more emergent because the model kind of understands that statistically, the kinds of landmarks that are in its training set are usually the prominent landmarks, the landmarks that people usually want to see, the kinds of landmarks that are usually very often talked about on the internet. And remember that the model already has a ton of knowledge from its pre-training on the internet. So it's probably seen a ton of conversations about Paris, about landmarks, about the kinds of things that people like to see. And so it's the pre-training knowledge that is then combined with the post-training data set that results in this kind of an imitation. So that's roughly how it makes sense. Okay, now I want to turn to the topic of LLM psychology, as I like to call it, which is what are sort of the emergent cognitive effects of the training pipeline that we have for these models. So in particular, the first one I want to talk to is, of course, hallucinations. For that we need an assistant. And we saw that we can actually have because of the fact, and this is and is what it is, which is a stochastic system that is really magical, but that you can't also fully trust. And you want to use it as a tool, not as something that you kind of like let it rip on a problem and copy paste the results. Okay, so we have now covered 2 major stages of training of large language models. We saw that in the first stage, this is called the pre-training stage, we are basically training on internet documents. And when you train a language model on internet documents, you get what's called a base model, and it's basically an internet document simulator, right? Now we saw that this is an interesting artifact, and this takes many months to train on thousands of computers, and it's kind of a lossy compression of the internet. And it's extremely interesting, but it's not directly useful because we don't want to sample internet documents. We want to ask questions of an AI and have it respond to our questions. So for that, we need an assistant. And we saw that we can actually construct an assistant in the process of post-training, and specifically in the process of supervised fine-tuning, as we call it. So in this stage, we saw that it's algorithmically identical to pre-training. Nothing is going to change. The only thing that changes is the dataset. So instead of internet documents, we now want to create and curate a very nice dataset of conversations. So we want millions of conversations on all kinds of diverse topics between a human and an assistant. And fundamentally, these conversations are created by humans. So humans write the prompts and humans write the ideal responses. And they do that based on labeling documentations. Now, in the modern stack, it's not actually done fully and manually by humans, right? They actually now have a lot of help from these tools. So we can use language models to help us create these data sets, and that's done extensively. But fundamentally, it's all still coming from human curation at the end. So we create these conversations, that now becomes our data set. We fine-tune on it or continue training on it, and we get an assistant. And then we kind of shifted gears and started talking about some of the kind of cognitive implications of what this assistant is like. And we saw that, for example, the assistant will hallucinate if you don't take some sort of mitigations towards it. So we saw that hallucinations would be common, and then we looked at some of the mitigations of those hallucinations. And then we saw that the models are quite impressive and can do a lot of stuff in their head, but we saw that they can also lean on tools to become better. So for example, we can lean on a web search in order to hallucinate less and to maybe bring up some more recent information or something like that. Or we can lean on tools like Code Interpreter, so the LLM can write some code and actually run it and see the results. So these are some of the topics we looked at so far. Now what I'd like to do is I'd like to cover the last and major stage of this pipeline, and that is reinforcement learning. So Reinforcement learning is still kind of thought to be under the umbrella of post-training, but it is the last third major stage, and it's a different way of training language models, and usually follows as this third step. So inside companies like OpenAI, you will start here, and these are all separate teams. So there's a team doing data for pre-training, and a team doing training for pre-training. And then there's a team doing all the conversation generation in a different team that is kind of doing the supervised fine-tuning. And then there will be a team for the reinforcement learning as well. So it's kind of like a handoff of these models. You get your base model, then you fine-tune it to be an assistant, and then you go into reinforcement learning, which we'll talk about now. So that's kind of like the major flow. And so let's now focus on
फाइन ट्यूनिंग पे आते हैं अपन अपना रीइंफोर्समेंट लर्निंग पे. आई थिंक लेट्स जस्ट कंप्लीट फाइन ट्यूनिंग. आई जस्ट वांटेड टू ये बिफोर वी look through this material and just get an overview of where we are in the overall pipeline of training models. Where does this fit overall?
बट कितना फैसिनेटिंग है ना, जबरदस्त है.
हाँ हाँ वो तो है भाई.
सोच के ही मजा आता है कि भी क्या धोया है.
बात तो है. Numbers, real numbers, it makes you think. Power of real numbers कितना है, right? It can basically map whatever that as a human you think you have created in this world. It can all be represented as just bits of numbers. All your thinking, all your ये, nothing but just a
उसमें और डबल क्लिक करेगा तो zeros and ones.
double click करेगा zeros and ones. Yeah. But imagine, मतलब वो बोलते थे कि नहीं, this whole world universe is nothing but it speaks a language of mathematics, and ये मुझे अभी कितना सही लगने लगा है ना. सोच के देखना ना यार, कितना जो अपन सोचते हैं कि हम इतने बड़े ये वो, but it's just numbers, right? just वेट के मैट्रिक्स है बस. वो पूरा ह्यूमन नॉलेज क्या 10 GB के हार्ड डिस्क में डाल के वो नंबर्स लेके तुम कहीं यहाँ चले जाओ मार्स पे, तो पूरे ह्यूमन का थॉट तुम्हारे पास है, राइट? और दो चार कुछ आर्किटेक्चर और कुछ अच्छा बनता है तो हो सकता है वो कुछ और इसमें कंप्रेस हो जाए, राइट? बट इसेंशियली दैट इज व्हाट इट इज, राइट? ही इज सेइंग कि वो एक कॉम्प्रेस लॉसी कॉम्प्रेशन ही सही, क्योंकि अभी आजकल का आर्किटेक्चर तुम्हें कुछ कंस्ट्रेंट्स डालता होगा, बट इमेजिन कि ये इम्प्रूव हो जाएगा और लॉसलेस हो जाएगा, तो वो इट्स नथिंग बट अ बंच ऑफ नंबर्स. It's scary as well as amazing. Yeah. Okay, हम यहाँ पे थे, right? Okay. Let's go through this. I don't think it has a video separately. So here's a base model is trained on raw data. There is that internet data to predict the next token. While the instruct model, जैसे उसने instruct GPT बोला था, is fine-tuned specifically to follow instruction and engage in conversation. For example, this is a base model and this is the instruct model. Is its instruction turn tune variant. Instruction turn models are trained to follow a specific conversational structure, making them more suitable for chatbot application. Moreover, instruct models can handle complex instruction, blah blah blah, multimodal inputs behind function calling. To make a base model behave like an instruct model, we need to format our prompts in a consistent way that the model can understand. This is where chat templates come in. Chat ML is one such template. Format that structures conversation with clear and here's a guide on chat. Common template formats. Before we dive into speaking implement is important to understand how different models expect their conversation to be formatted. We'll use the following conversation structure: role system, role user, role assistant, role user. Content: you are a helpful assistant.
So this chat ML is like ultra chat, what you were showing.
Ultra chat, I think he said, was for generating synthetic data nowadays, right? Chat ML looks more like a structure, like a template sort of. Chat ML is one such template format that structures conversation with बट इट डजेंट नेसेसरली से कि ये सिंथेटिक डेटा तैयार करेगा. वो बस फॉर्मेट देगा ऐसा लग रहा है, हालांकि वो चैट एम एल में बोलता हूँ तो लेके कहीं और ही जा रहा है. So this is the ChatML template used in models like ये and ये. Right? I am start similar I think what you just उस केस में user और ये यहाँ पे एक system वाला भी है. This is the Mistral template format. Right, so it looks like ChatML is a template of this type, but Mistral for instance uses this format. You are blah blah blah. Key difference between these formats include system message handling. Llama wraps system message in systex. Llama 3 uses Mistral uses system message the first instruction. Quen uses system. This ChatGPT uses system message boundaries and special tokens. Right, understanding these differences is the key to working with various models. Let's look at how transformer library helps us handle this variation automatically. Okay. So I think what these libraries will help with is कि given the basic sort of your sentences lines for each of those roles, हर एक मॉडल का लेकिन फॉर्मेटिंग अलग अलग है. तो लाइब्रेरीज डिपेंडिंग ऑन विच मॉडल यू आर सेइंग यू आर गोइंग टू वर्क विद, द लाइब्रेरीज विल प्रोबेबली हेल्प यू format them according to that model's needs. This will use different templates automatically. So auto tokenizer from ये तो Mistral tokenizer Quen और ये each will format according to this model's template. Right, तो जब मैंने इसने बोला मैसेजेस सेम है, बट क्योंकि ये मॉडल मिस्ट्रल का टोकनाइजर है वर्सेस क्वेन का है वर्सेस ये है, दे विल प्रोड्यूस दिस वर्सेस दैट. क्लिक हियर क्वेन एंड ये सब है मिस्ट्रल ना, ये एडवांस फीचर. चैट टेम्पलेट्स कैन हैंडल मोर कॉम्प्लेक्स सिनेरियोस बियॉन्ड जस्ट कन्वर्सेशनल इंटरैक्शंस इंक्लूडिंग टूल यूज when models need to interact with external tools or APIs. Multimodal inputs, handling images ये और ये, function calling for structured function execution, multi-turn context for maintaining conversation history. Multimodal conversation chat templates can include image references or basic super encoded images. Here's an example of chat templates with tool use. System user किसी ने पूछा कि what is 1 2 3 4 5 6. Right, so this is a template. तो in this case he is saying कि एक तो वो है कि आपका जो भी so these are all human generated, right? So ऑफ कोर्स आपका उस कंपनी का यूआई होगा, वो कुछ यूआई में इजी करके दे देगा कि ये सिस्टम का है, ये यूज़र का है, बट इसेंशियली यूजर्स आर टू राइट दैट आंसर. तो एक तो वो फॉर्मेटिंग करना है, दूसरा वो कह रहा है कि मल्टी मॉडल भी सपोर्ट करता है. तो जैसे इस केस में उसने बोला यूज़र पूछ रहा है अगर, तो दिस इज़ वन ऑफ द सैम्पल्स इट विल यूज टू ट्रेन ड्यूरिंग फाइन ट्रेनिंग. और इस चैट टेम्पलेट में उसने उसका स्ट्रक्चर दिया है, व्हाट इज इन द इमेज, राइट, बट द इमेज इटसेल्फ इज पार्ट ऑफ अ सेकंड आइटम इन दिस लिस्ट. सो चैट जीपीटी में शायद अपन जब अपलोड करेंगे एक इमेज और बोलेंगे व्हाट्स इन दिस इमेज, सम पार्ट इन दैट लाइब्रेरी शुड ब्रेक इट डाउन इनटू दिस फॉर्मेट. जो इमेज मैंने डाला है उसको इमेज यूआरएल ना से ही बेस 64 एनकोडेड स्ट्रिंग आ सकता है, या फिर ये हो सकता है, बट इस फॉर्मेट में डालेगा ये ऐसा. जैसे इस केस में, सो इट इज़ नॉट जस्ट अप्लाइंग दिस स्टार्ट एंड स्टॉप टैग्स एंड दिस, बट मल्टी मॉडल एज वेल एज टूल यूज. to then is it raining in Paris? So it made use of two tools. And there's a role called as tool also. Hands-on exercise. Let's practice implementing chat templates with real-world example. Follow these steps to convert Hugging Face Smalltalk dataset to ChatML format. Load the dataset. ये dataset load किया. Right. So hopefully these others. वो है जो ह्यूमन लेबलर्स ने जो डेटा सेट उसने एक दिखाया था, अलग दिखाया था, नॉट दिस वन. आई थिंक उसने कुछ ओपन
ओपन असिस्टेंट दिखाया था.
बराबर किया है कि मैंने यही है ना, हगिंग फेस टीबी स्मॉल टॉक. आई एम स्टार्टिंग कंटेंट रोल असिस्टेंट रोल यूजर कुछ है उसमें. राइट. अलग अलग सब्जेक्ट पे मैथ का है, ये का है. So you're saying follow these steps to convert this into a chat format. Now let's say you want to fine tune your model on the data set, but instead of just ऐसे करने पे आपको एक specific template format में उसको लाना पड़ेगा, तब जाके उससे ट्रेन करवाना है. So convert to ChatML example. Given an example, all you do is मैसेज में, रोल में, यूज़र में, कंटेंट में वो डालो जो एग्जांपल के इनपुट में हो, और एग्जांपल के आउटपुट में है वो असिस्टेंट का रिप्लाई है वैसे डाल दो. सो यहाँ पे भी इनपुट आउटपुट दिख रहा है क्या?
इनपुट आउटपुट मतलब क्वेश्चन आंसर. नहीं, यूज़र का रोल है और कंटेंट है, तो वो इनपुट हो गया, और असिस्टेंट का रोल है और कंटेंट है, तो वो आउटपुट हो गया. तो यू हैव द क्वेश्चन एंड द आंसर बोथ राइट इन द डेटा सेट. दैट्स व्हाट यू आर आस्किंग फॉर.
हाँ. No, I got the essence of what it is trying to do. I'm trying to see कि how does it work code wise, कि example में क्या पास किया गया है. Like example एक input है, right? Example is one of the record from this.
Yes.
Right?
You have content and role, right?
That's fine. ये content और role ये example में से नहीं ले रहा है. Example में से वो सिर्फ example मैप का, एग्जाम्पल डिक्शनरी में से इनपुट नाम का जो फील्ड है उसका वैल्यू निकाल रहा है और उसको कंटेंट को अप्लाई कर रहा है. तो बेसिकली इस एग्जाम्पल में क्या है इन द फर्स्ट प्लेस इज व्हाट आई एम ट्राइंग टू अंडरस्टैंड. क्योंकि एग्जाम्पल में अगर ये है, जैसे ये एक एग्जाम्पल में होता, तो एग्जाम्पल में फिर मैं ये चाह रहा हूँ कि फिर इस एग्जाम्पल में इनपुट नाम का एक फील्ड होना चाहिए था, और उस इनपुट फील्ड का जो कंटेंट था वो निकाल के मैं इसको अप्लाई करता, इसके कंटेंट में डाल देता मैसेजेस के. ऐसा कोड वाइज होना चाहिए, बट ये नहीं है इसमें इनपुट. ये इसमें ऐसे इनपुट नहीं है, और वो उसने कुछ आधा अधूरा ही किया है. ये जहाँ से कॉल हो रहा है वो दिखाया नहीं. ये जहाँ से कॉल हो रहा है वो अगर दिखाया होता तो मुझे और अच्छे से समझ में आता. वन रेफरेंस टू दिस, वो आगे जाके करेगा कि देखिए. ठीक है, बट आई थिंक ओवरऑल दैट वी नीड टू गेट इट इनटू अ फॉर्मेट. यहाँ पे देख लो है क्या, जस्ट इन केस. ओके, सो सुपरवाइज्ड फाइन ट्यूनिंग is a process primarily used to adapt pre-trained language models who follow instruction, engage in dialogue, and use specific formats. While pre-trained models have impressive general capabilities, provides a step-by-step guide to fine-tuning DeepSeek model using SFT trainer. By following these steps, by following these steps, you can adapt the model to perform specific tasks more efficiently. It is important as a first step, you should consider whether using an existing instruction-tuned model with well-crafted prompts would suffice for your use case, right? So find out if just doing prompt engineering would solve your problem. SFT involves significant computational resources and engineering efforts, so it should only be pursued when prompting existing model inefficient. Consider SFT only if you need additional performance beyond what prompting can achieve. Have a specific use case where the cost of using large language. Requires specialized output formats or domain-specific knowledge that existing models struggle with. If you determine that SFT is necessary, decision to proceed depends only on two factors. Right, so there is this SFT training which these big companies themselves have to undergo necessarily as part of their product. Right, so ChatGPT has gone through because they want to put out a helpful assistant out there into the world and make money out of it. But there is a base model associated with it, and then there is this SFT train model, and then there is refinement training, reinforcement training. In this case, उनका ही क्या यहाँ पे तो ओपन सोर्स वाले मॉडल उनका अगर मैं काम कर सकता हूँ तो वी हैव टू मेक श्योर कि आई जस्ट वर्क विद दैट, राइट? प्रॉम्प्ट इंजीनियरिंग से काम हो रहा है, बट नहीं हो रहा है और मुझे लग रहा है कि नहीं, बेस मॉडल पे मुझे SFT लगाना पड़ेगा, या बेस मॉडल ही क्या, हेड वाला भी अगर मॉडल है उस पर मुझे और एक SFT लगाना पड़ेगा. देन यू शुड रियली सी if it is necessary and then only do it. Template control SFT allows precise control over model's output structure. This is particularly valuable when you need the model to generate a response in a specific template format. तो एक स्पेसिफिक आउटपुट का ये चाहिए आपको, क्योंकि जनरल मॉडल्स नहीं दे रहे और तुम्हारा कोई बहुत ही खास यूज केस है, then you can think of that. Or domain adaptation when working with specialized domain technology and concepts enforcing professional understanding. The supervised fine-tuning process requires a task-specific data set structure with input-output pairs. Each pair should consist of an input prompt, an expected model response, and additional context or metadata. The quality of your training data is crucial for success. Let's look at how to prepare and validate your data set. The success of your fine-tuning depends heavily on choosing the right training parameters. Let's explore each important parameter and how to configure them. Training duration parameters. So, कितना epochs चाहिए? Max steps. Alternative to epochs at the maximum number of training steps. This I think is the number of training का size divided by batch into number of epochs, right? More epochs allow better learning but risk overfitting. Batch size parameters determine memory usage and training stability. Gradient accumulation step. Batches part. Larger batches provide more stable gradients, I think, because it accumulates gradients, so vanishing gradient का problem दूर हो जाएगा मेरे हिसाब से. But they will require more memory. Learning rate, warm up ratio, learning rate warm up too high, eval steps, monitoring requirement. Now that we understand the key components, let's implement the training with proper validation and monitoring. We will use SFT trainer class from Transformers Reinforcement Learner library, which is built on top of Transformers. Here's a complete example of the TRL library. तो उसने हेड वाला ही यूज़ किया है मॉडल। राइट, एंड उसका टोकनाइजर और मॉडल लेके आया और फिर यहाँ पे वो सेटअप चैट फॉर्मेट किया। ये कहाँ है सेटअप चैट फॉर्मेट? जो भी वो आधा अधूरा, वहाँ पे भी आधा अधूरा ही छोड़ा था उसका डेफिनेशन, यहाँ पे भी कहीं उसके रेफरेंस नहीं है। फिर उसके बाद वो बोल रहा है कि डेटा सेट तुम्हारा तैयार है, उस डेटा सेट को जिस फॉर्मेट में डालना है वो तैयार है, बट इस केस में उसने इसमें डालने के बाद क्या किया पता नहीं आ रहा है, यहाँ पे इसका फंक्शन ही नहीं है। तो बट होपफुली दिस इज नाउ, आई डोंट नो, बट अल्टीमेटली ट्रेनिंग आर्क्स लिया, ये सारे तुम्हारे हाइपर पैरामीटर्स हैं और हाइपर पैरामीटर्स को तुमने ट्रेनिंग में दिया, मॉडल को दिया ट्रेनिंग, और ये टोकनाइज़र ये सब दिया, राइट। सो ये मॉडल इक्वल टू मॉडल और टोकनाइज़र इक्वल टू टोकनाइज़र है। तो होपफुली मॉडल के पास वो जेट का फॉर्मेट है, तो ट्रेनिंग का जो भी डेटा सेट है इसमें से मैं सैंपल निकालूंगा बैच वाइज, राइट। जितना भी बैच साइज़ होगा उसका उतने मैं सैंपल्स निकालूंगा इसमें से और मॉडल को दूंगा। तो मॉडल का कोई तो पहले वाला पार्ट होगा जिसको उस चैट फॉर्मेट में डालेगा और उसके बाद उसकी ट्रेनिंग करेगा। सो सम प्री प्रोसेसिंग, बिकॉज आई एम गेसिंग एट द बेस्ट ये टेम्पलेट फॉर्मेट होगा। एक्चुअल इंस्टेंस तो जब आएगा तभी उसको डालना पड़ेगा। व्हेन यूजिंग डेटा सेट विथ मैसेजेस fields like the example this automatically applies model chat में, हाँ। So when using data set with messages field, the messages fields है क्या इसमें? data set with messages fields, कौन सा messages field बोल रहा है वो? अच्छा ये messages field। अगर इसमें messages ना, मान लो तुम्हारा डेटा सेट ही ऐसा है या मान लो तुम्हारा दूसरा भी है तो उसका नाम कॉलम का बदल के messages दे दो ताकि उनकी लाइब्रेरी उस कॉलम से है तो वो खुद ब खुद हैंडल कर लेती है। तो इस केस में वो क्या बोल रहा है कि मैं क्या करूँगा कि when using a data set with messages field, the SFT trainer automatically applies model chat template which it retrieves from the hub. Okay, this means you don't need any additional configuration to handle chat style conversation. This supports example packing to optimize training of this feature allows multiple short examples to be packed into a sample input. So you should know when to stop, right? And so you need to track your progress. So initial sharp drop, rapid adaptation to the new data distribution. That's why you see a sharp drop. Gradual stabilization, model fine-tune, convergence, loss variation is indicating reading completion. Which one is validation and which one is training. Effective monitoring involves tracking quantitative metric and evaluating qualitative metric available when your training loss, validation loss. Right, I think the point at which validation loss decreases and then at the point where it starts increasing again, that is when you know you have overfitting, and that is when you should stop. Right, watch for these signs during training. Validation loss increases while training loss decreases. This is overfitting. No significant improvement in loss values. That's underfitting. Extremely low loss values. And potential memorization. Inconsistent or temporary learning issue. What is the difference between number 1 and number 3? Why can't this also be seen as overfitting? Extremely low loss values.
It's saying that is called potential memorization.
Yeah, why not call it like overfitting?
Overfitting is when the validation loss is increasing while the training loss is decreasing.
So in this case, what is happening? Both losses are going down.
Yeah.
Then how is that a memorization? Because it has never trained on validation.
Basically, mm,
Monitoring training the gap above shows a dip in training progression. Notice of both training and validation loss decrease sharp advance and the engagement level of this pattern indicates the model is learning effectively while maintaining a generalized warning things to watch for. इसमें क्या प्रॉब्लम है? तो ट्रेनिंग तो सही चल रही है और ये इसने इसका पाथ फॉलो नहीं किया है, बट ड्रॉप कर रहा है. सिग्निफिकेंट नहीं किया बट किया. इज दैट बैड compared to this? The validation loss decreases at a significant slower rate than the training rate. Your model is likely overfitting to the training data. Okay, so overfitting कब कब है? एक तो यहाँ पे है, राइट, कि ये मेरा ट्रेनिंग था, ये मेरा वैलिडेशन था, और फिर आगे बढ़ता गया तो वैलिडेशन बढ़ने लगा और ये अभी भी कम होते जा रहा है, राइट. देन एट दिस पॉइंट यू स्टार्टेड ओवरफिटिंग. At this point you have started overfitting.
yeah.
But at the same time वो कह रहा है कि ये अगर ट्रेनिंग का डेटा था और तुम्हारा ऐसा था वैलिडेशन का, तो ये भी ओवरफिटिंग है. तो उसका कहना है कि ये जैसे शार्प उसने टर्न मारा, लेकिन वैलिडेशन डेटा पे वो उतना टर्न नहीं मार रहा, नीचे नहीं आ रहा है लॉस, इस पे आ रहा है, तो ये भी ओवरफिटिंग है. हालांकि मेरा मानना ये था कि एट द एंड ऑफ द डे तो वो यहाँ पे मोरलेस कन्वर्ज कर रहा है. तो इस पॉइंट पे जो भी वेट्स होंगे उसके, या फिर इस पॉइंट पे होंगे, उस पॉइंट ऑफ व्यू से देखे तो बस उसका पहले का कुछ पार्ट दे के हम इस निष्कर्ष पे कैसे क्यों पहुंचे कि ओवरफिटिंग हो रहा है और बंद कर दी है ट्रेनिंग।
क्योंकि your loss is so low on the training set, whereas on a validation set your loss is not low, which means कि तुमने overfit कर दिया है. Very clear.
That's not what I'm saying. See, लो दोनों केस में है। The only problem is
वो
this is
दोनों केस
not
में नहीं
following,
है ना.
है ना। ये भी तो ग्रेजुअली कम ही हो रहा है लॉस उसका।
हाँ, but
लॉस
तुम
यहाँ
if
पे
you
करने
take
का रीजन ये
at
है।
some kind of midpoint of that straight line of the validation curve, then you will see the difference in losses is huge.
Sure, that is my question.
So that's overfitting, right? Like basically your training loss is very very low,
नहीं ना,
but your validation loss is
फ्यूचर
not
में
that
देख
low.
के देखना, जैसे मैंने ये 0th आवर था, ये फर्स्ट आवर था, ये सेकंड आवर था। फर्स्ट आवर पे
Hmm.
तुमने डिक्लेयर कर दिया कि नहीं ये ओवरफिटिंग हो रहा है इसलिए बंद कर दिया। बट यही चीज़
Hmm.
तो 1 घंटे और चलाते तो ये मॉडल तो, और इस पॉइंट पे जितने वेट्स उसके होते और इस पॉइंट पे होते इक्वली होने चाहिए ना फिर तो। देन लाइक प्री मैच्योरली क्लोजिंग ऑफ दिस ट्रेनिंग, लाइक व्हाट डिड आई गेन। इस पॉइंट पे मैं हालांकि बंद क्यों कर रहा हूँ, क्योंकि मैं बोल रहा हूँ कि वैलिडेशन लॉस
क्योंकि यहाँ
लॉस
पे
बढ़ने
तुम्हारा
लग गया
सेकंड पॉइंट पे तुम
ना। आई एम
ऑलरेडी
टेलिंग यू इसमें क्वालिटेटिव डिफरेंस क्या है मेरे पॉइंट ऑफ व्यू से, है ना।
हाँ.
नॉट दैट बोथ आर इन सिंक इन टर्म्स ऑफ हाउ क्विकली दे आर ड्रॉपिंग।
Hmm.
आई एम नॉट सो मच कंसर्न अबाउट दैट कि हो सकता है वैलिडेशन लॉस या और हो सकता है ये, हाँ हाँ, शुरुआत में उसने कुछ कच्चे वेट्स डाले हैं जिसकी वजह से ये डिफरेंस हो रहा है उसका। बट माई पॉइंट इज कि ये एक अच्छे रेट में अगर ये रहा, ना कि उतना एक्सपोनेंशियल ना ही सही, बट अगर जा रहा है तो मैं अलाउ करूँ। हालांकि यही चीज़ मैं यहाँ पे नहीं करा, क्योंकि यहाँ पे उसने उल्टा होना चालू किया। उसने बोला कि मैं लॉस बढ़ा रहा हूँ, तो मेरा कहना है कि हाँ अब तुम बंद हो सकते हो, क्योंकि जितना सीखना था तुम सीख गए, अब तुम ज़्यादा सीख के इनफैक्ट तुम्हारा मेंटल फटीक हो गया, तुम कुछ और करने जा रहे हो। तो दिस मेक सेंस। बट दिस आई मतलब इस पॉइंट पे देखूँ तो मैं वो निष्कर्ष निकाल सकता हूँ दैट आई गेट। बट वही चीज़ मैं थोड़ा और रुकता तब तो फिर मैं आई वुड हैव प्रूवन रॉन्ग ना।
नहीं ना, तुम basically at that point one itself where you have labeled it as one, you know that your model is already so trained that the validation set is not giving a low loss, but the training set is giving a low loss.
करेक्ट।
समझ रहे हैं? So the difference is that in this case you have already overfit. You're getting it?
If
Whereas
I
in
am
the previous
overfit,
case, you can't say you have overfit because validation loss is also falling as quickly as training loss.
वो स्टिल मुझे इंट्यूशन नहीं आ रहा है उसका, क्योंकि देखना ये लॉस बहुत बड़ा है, मैं समझ रहा हूँ। इस पॉइंट पे मैं ये सोचूंगा कि यार ये तो कुछ न उसने ट्रेनिंग स्पेसिफिक ही कुछ सीखा है इसके वेट्स में। आई गेट दैट पार्ट, राइट। बट शुड आई कॉल ऑफ द ट्रेनिंग या शुड आई जस्ट कंटिन्यू एंड लेट इट ना। इस पॉइंट पे अगर देखें तो दोनों लगभग सेम है, मतलब विद द बेनिफिट ऑफ लाइक मैं आगे जाके विद द हाइंडसाइट 2020 के बेनिफिट में अभी मैं पहुंचू, तो यहाँ पे उसने तो कन्वर्ज किया ना। और यहाँ पे और यहाँ से इस पॉइंट से मान लो दोनों सेम ही रेट पे बढ़ते तो क्या होता।
So that is, you have the benefit of hindsight, but you have run it for, typically you run it for 3 hours and you have run it for 1.5 hours and you've realized कि यार ये validation loss तो गिर ही नहीं रहा है, training loss एकदम almost zero पे आ चुका है. Then you will think कि okay, there is something wrong, and you will not estimate that it will also continue to go down and eventually converge. So you will at that point say no, there is already overfitting happening, and it doesn't seem like it is in the right. Otherwise, you keep continuing, and the validation loss in the first case, which had gone up with might come down again, right? So, मतलब तुम you will have the benefit of hindsight in that case. But यहाँ पे at this point, if you have trained for a certain amount of time and you see that the training loss is already so low, then you can estimate that already overfitting is happening.
ठीक है. I think practically speaking, I get why company उस पे पैसा ना खर्च करे, क्यों करेगी. But just theoretically speaking, I was saying कि there is a possibility that it might still converge. But any case, I get what they say. So if the validation loss decreases at a significantly slower rate than training loss, your model is likely overfitting the training data. Consider reducing training steps, increasing data set size, and validating data quality and blah blah blah. इसमें क्या गलत है? इसमें लर्निंग ही नहीं हो रही है. दिस इज सॉर्ट ऑफ आई थिंक अंडरफिटिंग. If the loss doesn't show significant improvement, the model might be learning too slowly, struggling with the task, or hitting architecture limitation. Hitting architecture limitation is underfitting, right? Consider different model. ओवरफिटिंग का आंसर क्या होता था?
आंसर मतलब
What do you do typically? Forget deep learning, जो अपन ने लीनियर मॉडल में भी जनरल ज्ञान में, what do you do when you overfit?
your model curve uh, follows exactly the training data set curve, which is overfitting, right?
What do you do in that
Basically,
case?
what do you do?
Mm-hmm.
What do you mean by what do you do?
So you find out that based on your model architecture, it is overfitting. So how do you correct it?
You have to remake the model. Basically, your curve is like following the data sets too closely.
So constraining a model to make it simpler reduces the risk of overfitting or regularization. So this regularization वाला part था एक. The model is too complex. The possible solutions are to simplify the model by selecting one with fewer parameters to gather more training data. एक तो डेटा पे काम कर सकते हो, मॉडल पे यूज है कि मॉडल चेंज करो, सिंपल मॉडल ले लो, राइट? इट्स ताकि कंस्ट्रेंट करो, लाइक नॉट नेसेसरीली आर्किटेक्चर चेंज करो, वेल दैट्स आल्सो पॉसिबिलिटी आई थिंक. बट दूसरा था कि कंस्ट्रेंट करो, वो L1 और रेगुलराइजेशन वो भी एक था. और अगर वो अंडर फिट हो रहा है तो भी मॉडल चेंज करो, ज़्यादा पैरामीटर्स वाला ले लो, राइट? reducing the constraint, why increasing the constraint? But this is a case of underfitting, right? Or not? Underfitting का definition क्या था? It occurs when your model is too simple to learn the underlying structure of the data. Right? For example, it's too simpler a model to learn the underlying structure of the data. मतलब कितना भी करो, लॉस तो कम नहीं हो रहा है, कुछ सीख नहीं रहा है उस डेटा से.
वैसे ये validation set we started getting it in only for the deep learning models, right? Did we already have validation sets in the
linear models also? Yeah.
Linear regression also?
Yeah.
But test is different from validation.
Test is different from validation. Test is something you never even touch. That's only एकदम फाइनल, जिसको तो बिल्कुल ही नहीं देखना है. हालांकि वैलिडेशन में भी तुम एक्चुअली ग्रेडियंट डिजाइन नहीं कर रहे हो, तो उस हिसाब से आपने भरे उस पर वैलिडेट कर रहे हो उस पर, तो एक्चुअली उस सेंस में आप नहीं देख रहे उसमें. लेकिन वो टेस्ट में तो उसमें भी नहीं हाथ लगाते वैलिडेशन में. टेस्ट में
बट हमने ये वैलिडेशन सेट लीनियर रिग्रेशन और ये सब रैंडम फॉरेस्ट वो सब में वैलिडेशन सेट नहीं था हमारा.
ये पहले इसमें नहीं था. हालांकि कंसेप्चुअली मैंने 2-3 बुक देखे हैं जिसमें वो बोल रहा है कि हाँ उसमें भी रख दो वैलिडेशन, बट इसका जो ट्रेन ट्रेस टेस्ट स्प्लिट करके जो फंक्शन था, हाँ उसमें वो नहीं कर रहा था. उसमें वो टेस्ट को ही इसको यूज कर रहा था. बट बाकी सब आइडिया सेम थी, उसकी इवेल्युएशन वाली आइडिया सेम थी.
हाँ
If the loss doesn't show significant improvement, ये हो गया ना. हाँ, इसमें क्या प्रॉब्लम है? या प्रॉब्लम है भी कि नहीं है? ये डेटा सही नहीं है मेरे हिसाब से फिर तो, क्योंकि इतना क्लोज वो उसके साथ चल रहा है. इट्स एज इफ वैलिडेशन डेटा इज सेम एज टेस्ट डेटा. Extremely low losses values could suggest memorization rather than learning. Considering the model performs poorly on this is particularly considering the model performs poorly on new or similar example or next diversity. Responses are too similar to training examples. With the loss values and models actual outcome, I think sometimes the loss can look good while the model develop unwanted behavior. Regular qualitative evaluation. In section 1 where we will learn how to evaluate the model using benchmark data sets. Benchmark data set मतलब वो क्या सर वो रोज वगैरह वगैरह बस टाइप का. और now we'll focus on qualitative evaluation of the model after completing evaluate the model or hand out test data, validate template adherence across various inputs, test domain specific. Question answer करते हैं. What parameters control the training duration in SFT? So number epochs and max size तो है. Duration तो वैसे batch size और learning rate को भी करना चाहिए. Which parameters in the loss curve indicate overfitting? What is gradient accumulation step used for? Yeah. What should you monitor during SFT training? What indicates healthy convergence during training? Training loss reaching zero variation was being lower than इसका वीडियो है क्या? नहीं है. Fine tuning large language model is a resource intensive process. LoRa is a technique that allows us to fine tune large language models with a small number of parameters. It is by adding and optimizing smaller matrices into to the attention weights, typically reducing trainable parameters by about 90%. The parameter efficient fine tuning technique that freezes the pre-trained model weights and inject trainable rank decomposition matrices into the model's layers instead of training all models parameters during fine tuning. During fine tuning, LoRa decomposes the weight updates into smaller matrices through low rank decomposition, significantly reducing the number of trainable parameters while training the model. For example, when applied to GPT-3 175 billion, LoRa reduced trainable parameters by 10,000x and GPU required by 3x compared to full fine tuning. You can read more about here in the LoRa paper. So LoRa works by adding a pairs of rank decomposition matrix to transformers and is typically focusing on attention weights. तो ये अटेंशन वाले ब्लॉक में काम करेगा, फीड फॉरवर्ड वाले में नहीं. Right, during inference these adapter weights can be merged into the base model, resulting in no additional latency overhead. LoRa is particularly useful for adapting large numbers of specific domain while keeping resource requirement manageable. Only after parameters are stored in GPU memory, base model can be loaded in lower precision enables fine tuning of Zimmer GPUs. Training features. Native PEF to LoRa integration with minimal setup. Support for quantized LoRa, QLoRa for even better memory efficiency. Adapter management, adapter weighing, weight saving. Loading LoRa adapters with PEFT that provides unified interface for loading and manageable. For loading and management, LoRa, it allows you to easily load and switch between different PEF methods. Adapters can be loaded onto a pre-trained model with load adapter, which is used for trying on different adapters. So weights are merged. Set the active adapter weight with set adapter function to return the base model. Use unload to unload all this so he's saying कि पेफ्ट यूज़ करो, उससे क्या है कि तुम बहुत सारे एडवर्टाइज एक साथ ट्राई कर सकते हो और स्विच कर सकते हो और फिर देख सकते हो कौन सा अच्छा है कौन सा बुरा है, राइट। सो मान लो कि उसने ये यूज़ किया, ये मॉडल था और यहाँ पे उसने लॉरा मॉडल यूज़ किया। ये लॉरा है, ये कैसे पता चला? ये एक तो मॉडल दे दिया है, इससे पता चला गया। What the hell is this? It's a architecture. .3 MB में कुछ हो गया उसका काम। PEFT library. Okay, so LoRa adapters, personalized model, fine tuning, LLM using TRL and SFT trainer with LoRa. SFT trainer from TRL probably integration with LoRa. This means we can fine tune a model in the same way as we did with SFT, but use LoRa to reduce the number of parameters we need to train. We will use LoRa config class from the PEFT in our example. The setup requires just a few configuration steps. Define LoRa configuration, rank alpha and dropout, create a SFT trainer with PEFT config, train and save the models using TRL with this. And dropout scaling factor dimension. So dimensions of low rank matrices used for weight are typically between 4 to 32. Lower values provide more compression but less expressiveness. इसके केस में वो 4 था ना, 16 था और एक बार अपन ChatGPT से पूछते हैं, but उसके पहले when implementing PEFT method, start with small rank values 4 to 8 for LoRa and monitor training loss, use validation sets. Effectiveness so true configure. PEFT config में LoRa configuration डाल दो. The PEFT config. After training with LoRa, you might want to merge the adapter weights back into the base model for easy deployment. This creates a single model with two combined weights. The merging process requires attention to memory management precision since you will need to load both consistent precision throughout the process, matching the precision used for training and saving the measure. So this is the base model. This is the PEFT model. And then this is the merging. Dimensions, right? Dimensions. How does low rank decomposition work in LoRa based SFT? Explain with example with R+16. Given pre-trained bit matrix K into R ये B इंटू A करूँगा मैं तो D इंटू R इंटू K इंटू R बनेगा. ये मल्टीप्लाई कैसे होगा भाई? जो 16 इंटू 104 ठीक है. इस पे कुछ और देखना है. आई थिंक ऑल इट सेज इज
Conceptually, what they're saying is
Exactly.
you train a smaller matrix and you start with typically small, like 4, 8, 6, 8, and you can increase it later. But using that smaller train, like, are you training the matrice? I don't understand. How are you changing the weights of this matrix?
Through
And
regular
how is
training
it
process.
affect? Huh?
Through the regular training process, जो
नहीं, but where
epoch
does this matrix come into the play?
ट्रेनिंग के पार्ट पे ना, so
नहीं, but it's not there in the model,
it's not there in the
right?
model. Yeah.
So you're not changing the model weights, but you are changing the weights of this matrix, and it will affect the model weights or what?
It will so there are two things. There's a model ka architecture and model ka weights. You're not changing the model ka weights, in fact you are freezing them so that you
Correct.
don't change them. That's the whole idea, right? आर्किटेक्चर में इट डज चेंज, क्योंकि अभी तुमने कुछ लो रैंक मैट्रिक्स और हाई रैंक मैट्रिक्स जो अप स्केल और डाउन स्केल अप करने का जो मैट्रिक्स है वो डाला उसके बीच में, राइट, डिटरमाइंड बाय दिस फैक्टर रैंक डिमेंशन। वो डालने का मतलब है कि उस मॉडल में तुमने एक और लेयर सॉर्ट ऑफ एक और वेट्स ऐड किए, लेयर नहीं वेट्स ऐड किए। तो इससे जाओगे तो वो क्या बोल रहा है कि उनमें ये जो एग्जिस्टिंग वेट्स है उसके थ्रू तो जाएगा, बट उसमें वो वेट्स को चेंज नहीं करोगे तुम, बट इसके थ्रू भी जाएगा, ए और बी के थ्रू। सो द ओरिजिनल वेट्स W0 आर फ्रोजन, so they are not updated during fine tuning. Only parameters within A and B are trainable. Input X passes through W0 as usual, राइट? तो फीड फॉरवर्ड में तो जाएगा ही उसमें से, भले ही फ्रीज किया हो, फ्रीजिंग का मतलब है कि बैक प्रोपगेशन नहीं होगा, फॉरवर्ड तो जाएगा उसमें से। साइमल्टेनियसली इट इज ऑल्सो पास थ्रू ए एंड बी, राइट? एंड दिस आर द वेज यू आर ट्राइंग टू ट्रेन लर्न। एंड फाइनली आउटपुट फ्रॉम W0X ओरिजिनल प्लस ये आर समड अप टू गेट द फाइनल आउटपुट। तो ये तुम्हारा प्रेडिक्शन देगा, ये प्रेडिक्शन के साथ तुम लॉस और वो सब बाकी सब चीज़ें करोगे और फिर बैक प्रोपगेशन करोगे। बैक प्रोपगेशन में हालांकि सिर्फ ए और बी अपडेट होते जाएंगे, W0 नहीं होगा। और फाइनली नंबर ऑफ इपॉक्स और वो सब इवैल्यूएशन मैट्रिक्स के साथ जब तुम सेटिस्फाई होगे तुम ये बंद करोगे, इसका मतलब ए और बी अब सीख गए हैं, W0 वैसे भी कभी चेंज नहीं किया था। और फाइनली वो बोलता है कि ये सब होने के बाद ए और बी को इसमें मर्ज कर दो, क्योंकि मॉडल में तुम्हारा ये अलग से पड़ा हुआ था, पहले का W0 था एक मैट्रिक और ये अलग से पड़ा हुआ था। बट अल्टीमेटली तुम्हारा मॉडल का आर्किटेक्चर क्या है, 1024 इंटू 1024 है। ये तुमने एडिशनल दो चीज़ें 1024 इंटू 16 और 16 इंटू 1024 एक दो अलग से मैट्रिसेस लगाए हैं, वो सब उनको इकट्ठा करके वापस उसमें डाल दो। तो इसका मतलब मर्ज्ड आफ्टर मर्जिंग you have effectively fine-tuned your model on new data set without having to disturb so many parameters, but by disturbing only some of these parameters. And this is that part is saying कि यहाँ पे merge कर दो, merge का implementation
Is there a graph we can ask it to show whereby we can visualize this A and B?
what do you mean?
Like, I know it's like at the end of the day it's a neural net, right?
At the end of the day this is the training and these are the evaluation sets that you typically, जो इसमें एग्जाम्पल दिखाया ना उसने फाइन ट्यूनिंग विद SFT ट्रेनर, उसमें और इसमें क्या फर्क है? तो दोनों SFT ट्रेनर ही ले रहा है, जस्ट दैट कि इसमें सारा ही तुम्हारा वेट्स ट्रेन हो रहा है, इसमें सारे नहीं।
मैं समझ रहा हूँ।
हाँ नहीं, मैं I'll get to the point. So to your point कि नहीं कि कोई तुम्हें सीख कैसे रहा है नया, ये इसमें भी तो अपन स्पेसिफिक लेयर कैसे सीख रहे हैं वो तो नहीं देख रहे थे ना, इसमें भी अपन पूरा मॉडल कैसे सीख रहा है वो देख रहे थे, है ना? ये जो लॉस है वो हाउ मॉडल एज पार्ट ऑफ फाइन ट्यूनिंग इज डूइंग इज व्हाट इट इज टेलिंग यू। In this case also when you use the same sort of criteria evaluation वाला जो भी तुम यहाँ पे डालोगे तो तुम्हें ग्राफ्स तो वही बताएगा, ये इवैल्यूएशन जो भी यहाँ पे उसका ट्रेनर डॉट ट्रेन में जहाँ पे भी वो इवैल्यूएशन के मैट्रिक्स लेता है, ग्राफ तो वही दिखाएगा। इनफैक्ट नाउ यू नो, क्योंकि तुम्हारा वो फ्रोजन है बाकी के सारे वेट्स, ये जो ग्राफ दिख रहा है वो प्रिसाइसली फॉर द न्यू ए एंड बी ही है, इतना तुम्हें पता है क्योंकि बाकी कुछ चेंज ही नहीं हो रहा है, राइट? तो इन फैक्ट इफ यू सी दिस ग्राफ, सिमिलर ग्राफ फॉर LoRa, आई थिंक वन कैन एज्यूम कि दिस इज प्रिसाइसली फॉर द न्यू वेट्स दैट आर लर्निंग ए एंड बी.
The graph I meant was not this graph,
हाँ,
like the graph of the neural net, and we know what the weights look like. And when we are adding this A and B matrix into it, like where are we adding it?
okay, वैसा
Just
वैसा.
from a neural net graph standpoint.
हाँ, तो वो उसने बताया था कि उसने अटेंशन ब्लॉक में डालता है, बट वी कैन आस्क.
We know it's in the attention block, but what does it look like graphically? ये इसने एक नया चालू किया है ना, ऐसे आउटपुट देना. This wasn't there before.
Alright, so input is going to this. Input is also going to this. और ये अप डाउन करने के बाद बेसिकली तुम सम करके उसका फाइनल आउटपुट निकालते हो, उसका लॉस निकालते हो, जिसके बैक प्रोपेगेशन करोगे. इसके थ्रू जाएगा नहीं, इसके थ्रू जाएगा, एंड देन यू विल रिपीट.
Got it.
I think evaluation let's do, and then maybe stop for the day. Evaluation. With fine-tuned model through either SFT or LoRa SFT, we should evaluate it on a standard benchmark. As machine learning engineers, you should maintain a suite of relevant evaluation for automatic benchmarks. Security data sets. It is crucial to understand that the benchmark performance doesn't always translate to real world. General knowledge benchmark. So massive multitask language understanding test. I'm searching to humanities where reasoning benchmark. Complex reasoning task may be just logical thinking, planning, mathematical. Helm. It's holistic evaluation paper. Domain specific benchmark. Let's look at a few benchmarks that focuses on specific domains like math, coding, chat, human evaluation. Alpaca. Alternative evaluation approaches LLMS judge. force feedback. Only visible asking questions and voting on which model provides better. There is a bench capacity and one is dependent on changing benches. Custom benchmark suits. Specific requirements and challenges for you to discuss what to see. Light eval. So I think set up an एक example देख ही लेते हैं इसमें ना. Let's set up an evaluation pipeline for our fine-tune model. तो यहाँ पे मेरा model था. We will evaluate the model on a set of subtasks that relate to the domain of medicine. Here's a complete example of evaluating or an automatic benchmark relevant to one specific domain using light eval. So light eval से वो सारे जो मॉडल्स अपना अपना benchmark प्रस्तुत करते हैं. I guess they use some tools like light eval to do that and then provide the right benchmark and then their model. इसमें कोई ऐसा तो नहीं है राइट कुछ LM एरिना एक वो था उसका देख लेते हैं अपन. बैटल साइड बाय साइड कंपेयर टू मॉडल साइड बाय साइड. क्लाउड ग्रॉक ठीक है भाई. चैट और इमेज. बता भाई. Who is going to win IPL 2025?
क्लाउड ने तो पहले ही हाथ खड़े कर दिए. मेरे को तो 24 का ही पता है. आई कांट से एनीथिंग अबाउट.
वैसे
वाह.
क्लॉड एज कंजर्वेटिव आंसर दिया लेकिन अच्छा है इस केस में. इसने तो स्पेक्युलेटिव टेक में चेन्नई सुपर किंग को भी रखा है कि कोलकाता नाइट राइडर को.
हाँ बट ग्रॉक शुड नो ना कि they are not in the finals. Already eliminated हो गए.
एग्जैक्टली राइट. सो मान लो इसको टूल्स का एक्सेस नहीं है इनके होस्टिंग में तो बेसिक मॉडल के ट्रेनिंग में उसने बोला था ना कि हेल्पफुल ट्रूथफुल वो सब होना चाहिए. हालांकि आई एम नॉट नेसेसरली उसने बोला है कि मैं स्पेक्युलेटिव टेक है. इसमें कल क्योंकि मैं इसको पूछ रहा था गूगल को तो उसने तो बोला जेमिनाई ने कि हाँ but then it has access to web search and everything. तो उसने बोला कि कौन ये पहुंच गई है आरसीबी। मैंने पूछा दूसरी कौन है फाइनल में, तो बोला नहीं अभी तो वो डिसाइड नहीं हुआ है, इसके बीच में ये मैच होगा, उसके बीच में वो होगा। वो सब उसने सही से बताया।
This is not new. Like this didn't need LLMs. All this predictor and all they used to have many years ago. Like 10 साल पहले भी था predictors. For big sporting events, you would search who will win and it will predict. Especially Bing had popularized this.
Being it popular is what?
Um, Sport predictions, like upcoming games के predictions. So you could see prediction values of a game even before the game happened. Obviously, prediction before you know.
हाँ, but
But
then those are not models ना। I mean
they
those
were
are
not
statistical
LLMs.
model, और हाँ those are not ये ट्रांसफॉर्मर मॉडल टाइप का।
Hmm.
वो गूगल अभी भी देता है कि पता नहीं, बट हाँ मैच के बीच में देता है। बिंग पे तो चालू किसने किया तो पता नहीं, लेकिन मैं गूगल तो दिखाता है आईपीएल में, फुटबॉल उड़ो सभी में होगा तो होगा ऐसे। बट ये एक है एलएम मरीना, और क्या है इसका साइड बाय साइड डायरेक्ट चैट बैटल। बैटल बैटल करते हैं। कन्विंस कन्विंस इसको ये करते हैं, ये इसमें नहीं होता है। कन्विंस मी दैट climate change is a hoax. चला गया था भाई। अच्छा, बैटल में उसने ये नहीं दिखाया कि कौन सा असिस्टेंट है, प्रिजुडाइज ना हो, बस लेफ्ट अच्छा है कि बुरा है इतना बताओ, ताकि अच्छा है। आई डू माई बेस्ट टू प्रेजेंट द मोस्ट वार, इतना तो बहुत गया। इसका पहले पढ़ते हैं। आई एम टू हेल्प यू अंडरस्टैंड द साइंटिफिक एविडेंस एंड कंसेप्ट्स ऑफ क्लाइमेट चेंज रादर देन प्रमोटिंग ईदर स्केप्टिसिज्म और अलार्मिज्म। बाद में ये
पहले से ही बोल दिया, I can warn you upfront, I won't succeed in convincing you.
नहीं, इनफैक्ट ये वोक लग रहा है मुझे।
नहीं, मैं लेफ्ट वाला दिख रहा
अच्छा
हूँ।
लेफ्ट वाला क्या? अच्छा मैं राइट राइट
हाँ,
का बता रहा है। ये तो बोला नहीं भाई, मैं बोल रहा हूँ कि मुझे कन्विंस कर। तो बोला नहीं, वो कैसे कन्विंस करूँ, है ही नहीं बोल रहा है वो सच्चाई।
नहीं वो तो दोनों हैं because the left one is saying
अच्छा
I must warn you, I won't succeed in convincing you that
अच्छा
climate
अच्छा।
change is.
बस वैसे
So,
ridiculous.
both are saying in a way the same thing.
I can walk you through the key evidence and data if you are interested in examining what particularly. Generally curious and which is make you skeptical. अच्छा ये क्या बोल रहा है? I'll do my best. I won't succeed in convincing. I must warn your friend. I won't succeed in convincing other languages. Yes, as climate has been going to blah blah blah. The current rate of change is 10 times faster. Lima are regionally localized, not a global phenomenon. See the unprecedented temperature records are unreliable. ये उसके ये है क्लाइमेट चेंज नेचुरल साइकिल हैज हैपेंड बिफोर। एटलीस्ट उसने कुछ तो आर्गुमेंट्स दिए, है ना? Let's dive into the skeptic playbook and I'll provide counterpoints to each argument demonstrating why they are flawed. उल्टा बोल रहा है वो, लेकिन हालांकि दोनों पर्सपेक्टिव तो दे रहा है, राइट? तो क्लाइमेट चेंज इज द नेचुरल साइकिल, इट हैज हैपेंड बिफोर, सो आई कैन मेक दैट आर्गुमेंट टू से दैट क्लाइमेट चेंज इज अ होक्स। The temperature records are unreliable. There is no warning. It's the sun's activity, not humans. Climate models are flawed and can't predict the future. Scientists are conspiring for funding and fame. Volcanoes and animals produce more CO2 than humans. Finally, observed consequences regardless of theoretical debates, climate change impact. ठीक है भाई, किसको बेहतर बताएगा? I'll say left one is better तो, क्योंकि उसने कुछ कॉम्प्रिहेंसिव ये तो बताया मुझे।
अच्छा, it was Llama 4 Maverick. It's telling it now.
तो
Right one is closed.
बोर हो रहा होगा तो तू दुनिया की ऐसे मदद कर सकता है.
दुनिया की मदद.
ठीक है, आई थिंक लेट्स स्टॉप फॉर द डे देन.
Yeah.
ये
I
क्या?
think this evals is a big topic,
हाँ.
and from what I'm hearing, like most companies are spending most of their time now on fine tuning and evals. That's it.
What do you mean? What do they do as part of evals?
Like really make sure that the model you have made is is beating or meeting some certain benchmarks and your own internal benchmarks like you are making to understand whether the model is performing well or not. So that's become a the biggest part of like the effort being expended by most companies, both on the model side as well as on the corporate side.
बट ये लोग जैसे कंपनी कॉर्पोरेट साइड तो ठीक है, कुछ तुम्हारा कस्टम इवैल्यूएशन मेट्रिक है. आई एम नॉट श्योर कैसे कितने कंपनीज है जिनको मैं बोलूँ कि मेरा ये साइंस को बीट करता है, मैथ्स को बीट करता है, लैंग्वेज जनरेट करता है, ये करता है, उसके बावजूद कितने कंपनी को लगता होगा नहीं नहीं मेरा कुछ एक अलग बेंचमार्क होना चाहिए. दैट असाइड, बिग वेंडर कंपनीज में हर एक जना बेंचमार्क पे क्या काम कर रहा है. बेंचमार्क शुड बी वन कॉमन थिंग एंड यू शुड जस्ट अप्लाई एंड टेस्ट. योर मॉडल कैन शो अ डिफरेंट रिजल्ट कि कुछ बेंचमार्क फेल हो सकता है, उसके हिसाब से तुम चेंज करोगे, वो अलग बात है. बट बेंचमार्क इवैल्यूएशन इन इटसेल्फ पे क्या काम हो रहा होगा.
Like you're trying to meet and beat benchmarks
या
as OpenAI, as Claude, as Grok,
राइट.
and you are also trying to come up with new benchmarks which will prove why your model is better than other models. So there's a lot of work happening in this space on evals. तो ये थोड़ा हमको सर्च करके देखना चाहिए and see like what we need to learn out of it. It's not just a small topic as they have shown it here. It's a massive topic in itself, and it is becoming more and more so.
राइट, बट फ्रॉम माई पॉइंट इज कि क्या ये जैसे इंजीनियरिंग पॉइंट ऑफ व्यू से सीखने लायक टॉपिक है कि लाइक दिस इज़ वेरी सेंट्रिक टू द मॉडल क्रिएटर्स, और वो है जैसे आई एम ट्राइंग टू अंडरस्टैंड LLM, उसके एप्लीकेशन, तो उसके पॉइंट ऑफ व्यू से मुझे इवेल्यूएशन उतना डीप में घुसना चाहिए कि मुझे जनरली कहीं पे भी मैं ये अप्लाई कर सकता हूँ, या दिस इज लाइक अ वेरी स्पेशलाइज्ड थिंग इन अ स्पेशलाइज्ड कंपनी.
I think घुसना चाहिए in the sense के you need to understand how the models are performing on different eval metrics and why they are performing so and what you can change in the model. Can you tune hyperparameters? Can you do different kind of fine tuning? Can you train the model in a different with a different data set? All these things which are important for a data engineer slash data scientist slash model maker eventually comes to the front to the rest of the world as eval metrics.
ठीक
I
है,
think,
कुछ मिले तो बताना मुझे इस पे, अपन we can go through that.
हाँ, we can search more about it and figure out if there are specific videos we can step out and do a little bit more on evals. At the same time, we can say no, we can come back to it later. We will focus on, for example, building our own and fine tuning and training our own model now, and we will come to eval later. But ये eval as a topic हमको देखना चाहिए.
ठीक है, इसने तो नहीं बताया था ग्रोक ने, बट वी कैन फिगर आउट और कुछ है तो.
तो अभी हम लोग डिप्लॉयमेंट पे आ चुके हैं क्या? इसमें हमने एजेंट्स वगैरह आया था क्या?
नहीं, पहले LLM में उस दिन हमने किया ना डिस्कस, एजेंट्स का
नहीं
अलग ये है टॉपिक.
in terms of our plan for 2 months, did we have agents?
या
It is there, no? हाँ.
एजेंट्स है, MCP है, राइट. बट एजेंट MCP, आई थिंक these are relatively simpler thing, दो ऑलरेडी हाइप
Yeah,
है
yeah,
होगा.
of course.
there's nothing but just calling API some form of orchestration.
हाँ
हो सकता है, तो उस हिसाब से ठीक है. Efficient serving. हाँ, but efficiency deployment ये थोड़ा देखना पड़ेगा आपको. फाइन ट्यूनिंग तुमने सीख लिया भाई. क्यूलोरा क्वांटाइजेशन. न्यूरल नेटवर्क तो तुम्हें आता है अभी, है ना. ट्रांसफॉर्मर आर्किटेक्चर तो बहुत डीप डाइव हो चुका है. नैनो जीपीटी भी हमने बिल्ड किया है. एलएलएम के फंडामेंटल तुम्हें आते हैं. मॉडर्न आर्किटेक्चर, स्टेट ऑफ द आर्ट, टास्क एक्सपेरिमेंट विद ओपन सोर्स मॉडल्स. बहुत सारे ओपन सोर्स के साथ बनने. कंपैरेटिव अटेंशन वेरिएंट्स. ये अटेंशन वेरिएंट्स में और ज़्यादा नहीं घुसे हैं, बट ठीक है. फाइन ट्यून लोरा वाला था, क्यों लोरा वाला था. ये चाहिए तो
अल्पाका.
कर सकते हैं. कंपेयर टोकनाइजर्स हमने किया. इम्प्लीमेंट सैम्पलिंग मेथड्स. ये थोड़ा थियरी पड़ा था, ज़्यादा नहीं. हाँ, तो एक हाथ प्रोजेक्ट चाहिए तो जैसे ये कर सकते. जनरेट शॉर्ट स्टोरीज विद डिफरेंट सैम्पलिंग सेटिंग्स एंड कंपेयर एप्लीकेशन. RAG AI agents is fine. Deployment of AI model itself is something we can look at. We should look at. क्योंकि अभी जो हम कर रहे हैं वो खैर हगिंग फेस बिहाइंड द सीन
मैनेज कर रहा है.
मैनेज कर रहा है. बट वो अल्टीमेटली, बट आई थिंक इट कैन गेट टू मच इनटू टिप्स बीट्स, क्योंकि a lot of
हाँ
it will also depend on your actual infrastructure, which we are not like. तुम स्केल पे समझना चाहते हो कैसे, तो वो डिस्ट्रीब्यूटेड जीपीयूज यूज होगा. या तुम सिंगल जीपीयू पे सीखते हो, या लोकल पे सीख सकते हो, या क्लाउड पे सीपीयू पे सीख सकते हो. और उसके लिए थोड़े चेंज करने पड़ेंगे वगैरह वगैरह. तो आई थिंक पूरा तो पॉसिबल नहीं है, बट हाँ, एफिशिएंट सर्विंग क्या है, एक हाई लेवल अपने को व्यू कर सकते हैं अपन. Cloud GPUs if local hardware can't handle 70B model. Efficient serving is a key for this. Open source and stable contributor long chain contribution तो ठीक है. Cutting edge and efficient serving.
इसमें हम लाइन चेन, लाइन ग्राफ वगैरह पे आए नहीं ना.
हाँ, क्योंकि वो आई थिंक उसमें ज़्यादा आएगा जब अपन रैग और AI एजेंट्स करेंगे तो. क्योंकि मॉडल के अराउंड जो भी करना है दैट इज आई थिंक प्राइमरीली पाइटॉर्च एंड हगिंग फेस जो अपन
राइट.
यूज़ कर रहे हैं. बट अगर तुम्हें बहुत सारी चीज़ों को ट्रेन ये करना है कि पीडीएफ से तुम्हारा डेटा देना है, उसको प्रॉम्प्ट में डाल के उसको आगे भेजना है वगैरह वगैरह, वैसा करना है तो वो लैंगचेन काम में आएगा. Agents, document loaders, streaming, chat models. But in short, I think what LangChain does is not with respect to models. Like model कहीं पे और hosted है और तुम्हारे पास उसका API की है, मान लो ओपन AI का, तो वो ओपन AI का API की अपने में डाल के तुम्हारे सर्विस में, तुम्हारे माइक्रो सर्विस में, तुम्हारे प्रोग्राम में डाल के तुम यहाँ से जो जो भी कर सकते हो. राइट. जैसे कन्वर्सेशन हिस्ट्री तुम्हारे पास पड़ी है तो उसको बिल्ड करना तुम्हारे कॉन्टेक्स्ट में. पीडीएफ में से कुछ डेटा रैक के फॉर्म में डाल के भेजना वगैरह वगैरह. चेन करना, इसका रिस्पॉन्स आने के बाद किसी और ML LLM को भेजना है वगैरह, उस टाइप का. आई थिंक इट इज ऑफ दैट outside of the purview of this. Let's come back.